Scientific notation. A number is written in scientific notation if its significant digits are expressed as a number between 1 and 10. And that's including 1 but not including 10. And those significant digits are being multiplied by some power of 10. For example, 5.28 times 10 to the second is in scientific notation. 1 times 10 to the fifth is in scientific notation. 9.915 times 10 to the negative 14th. These are all in scientific notation. Examples of numbers that wouldn't be 52.8 times 10 to the fourth. This number is not between 1 and 10. 10 times 10 to the third. This number has to be less than 10. It could be 9.999 if it wants, but it has to be less than 10. To convert from decimal to scientific notation, we're going to move the decimal to the left or the right until we have the number between 1 and 10 that we want. We're going to count how many times we had to move the decimal, and that will be the exponent for the 10. If we moved the decimal to the left, meaning that the original number was larger, then our exponent is going to be positive. If we moved it to the right, meaning our original number was smaller, the exponent is negative. So looking at 6,380,000, I need to take this number 6380000. It has a decimal right here. In order to have a number between 1 and 10, that decimal needs to be moved here. That'll give me 6.38. So that's going to be the significant digit part. What I need to do is figure out what is this exponent. Well, how many times did I move it? 1, 2, 3, 4, 5, 6. I moved it 6 times, and in moving it 6 times to the left, I took a very large number and turned it into a very small number. In order for this large number to be the same as this small number, I need to multiply by a large number. So that's why this 6 is positive. You can memorize that if you move left, then it's positive. If you move right, then it's negative. I just like to be able to think through it. You have a very large number here. We've turned it into a small number, so we need to multiply by a very large number. Alright, looking at 0.000000159. I need to turn this into a number between 1 and 10, so I guess it would have to be 1.59 times 10 to some power. So I'm going to have to move my decimal here. That's 1, 2, 3, 4, 5, 6, 7 spots to the right. So it's going to be a 10 to the 7th. The question is, did I make this really tiny number bigger? I did. 1.59 is huge compared to this thing. So what I need to do is multiply by a very tiny number. That's why I'm going to have a negative exponent. Working the other way, we're just moving the decimal again. We're going to move it to the right or the left. We'll move it left if it's negative, which will create a smaller number, or move it to the right if it's positive. So if we have 7.6, we need a teeny tiny number, so it's going to go 1, 2, 3, 4, 5, 6 spaces. This is where my decimal is going to be now. I need placeholders for all of these. And so my final answer, 0.12345 zeros, a 7, and a 6. 3.86 times 10 to the 5th. Again, I've got 3.86. I need to move the decimal 5 places to the right. 1, 2, 3, 4, 5. So that's where my decimal is going to go. I need some zeros to fill in gaps. And so my final answer is 386,000. We need to know how to multiply numbers in scientific notation. One option is to convert from decimal, or from scientific notation to decimal, do the multiplication, and then convert back. So we'd have, in this case, 170,000,000 times 24000. And when we multiply that out, we get 4080,000,000,000, or 4.08 times 10 to the 12th. Now that can be a pain. So oftentimes it's easier to just multiply the two numbers in front. So 1.7 times 2.4, and then multiply the two numbers in the back. 10 to the 8th times 10 to the 4th. 1.7 times 2.4 is 4.08. 10 to the 8th times 10 to the 4th is 10 to the 12th. That looks much easier. However, we have to be careful with that process, because sometimes we end up with an answer that needs an adjustment. Looking at this one, 3 times 10 to the negative 2nd times 5.1 times 10 to the negative 4th gives us 15.3 times 10 to the negative 6. But I don't like that answer. Why not, you may ask? It's not in scientific notation. The 15.3 is too big. It's bigger than, it's not a number between 1 and 10. So we're going to have to adjust the decimal a little bit. Now, again, there might be tricks to use to, well, if you move it to the left, that changes this one way or the other, and I can't remember those tricks. So what I'm going to do is just remember that 15.3 is 1.53 times 10 to the 1st. So that means I can rewrite 15.3 times 10 to the negative 6 as 1.53 times 10 to the 1st. That's this 15.3 part. And then bring along the 10 to the negative 6 for the ride. But here I have a base to a power and that same base to a power, so I can pretty that up a little by combining those terms. We get 1.53 times 10. 1 plus negative 6 is negative 5. And that gives me my answer.